Hi and welcome back to video 2 of our topic on our module on cells, tissues and organs. This is Gaffy's Grinds, the channel where we take concepts and we break them down and we try and make them simple to understand. And we do lots of practice to make sure that you actually learn the information and it goes to your long-term memory where it becomes useful to you in your lives. The usual reminders before we start, guys. In these lessons, we try to make sure that we always try to make sure that we avoid distraction, and we do this by putting our phones on silent, or better, turning them off. And we make sure that we try our best to do all of the tasks because we know that that's going to help stuff go in our long-term memory. And again, there's no point in watching the videos if you're not going to try your best to do all the questions and the tasks. You just won't learn anything. Okay, so this video is going to be about microscopes and magnification. So before we begin, we're just going to take a look at a really cool simulation. This is one of my favorite simulations. I just have to share a different screen with you for a second. And this is the simulation right here. If you're interested, if you Google scale of the world, this is scale of the world 2. This is what this is called. You will be able to find the simulation and have a go at it yourself. Now, what is a scale? A scale is where we put things on, where we can measure things based on a certain size. So this scale measures different things based on their size. So we can zoom in and we can zoom out. That's what we're going to be doing here. Now, as you can see on the screen here, we've got at the top of the page here, 1 meter. Now, these are things that we would measure using the unit, which is a meter. So I'm sure you guys have a rough idea what a meter is. We've seen a meter stick in school before. It's about 3 times the length of your ruler that you would have in your bag. It's about 3 times that length. That's 1 meter. And we are used to dealing with things in our everyday lives that are measured in meters. That's that to us, things that are in meters are normal. So the height of a person is measured in meters. So this is, our eyes are actually evolved and trained to see things that are measured in meters. Cars are about 2 meters to 3 meters, depending on the size of the car. Basketball, as you can see on the screen, is not quite a full meter. It's not quite 1 full meter. It's like probably a third of a meter or something like that. That Russell's teapot, as you can see there. These are things which we would measure in meters, but they wouldn't be a full meter. The inch ruler is like a 30, I think it's 30 inches, and it's about a third of a meter, as we said already. So this is the scale that we're used to dealing with things. If I just zoom out just a little bit here, you can see other things that are measured in meters are humans. Compared to a human, you can see that the beach ball is smaller, but beach ball is about the same size as a dodo bird there. Okay, so these are all what we call measured on a scale of a meter. But things can be much bigger than a meter, and humans can't always appreciate things which are much, much bigger than a meter. So the first thing we're going to do is we're going to start zooming out. So go into a bigger scale than 1 meter. So as I zoom out here, I am going to a larger scale. Now, all of these things are still measured in meters, but they're much bigger than a human. You can see the human there in the background, I'm hoping in the middle. It's now very small compared to these things, but these things would still be meters. We wouldn't be using a bigger unit, okay? So an oak tree is still a meter. It's still measured in meters, but we're probably talking maybe 20 to 30 meters now, okay? Here are some of the dinosaurs, okay? So some of the old dinosaurs. These are measured in meters. We have a plane, for example, the Statue of Liberty. All these things are still measured in meters. The Titanic. We're getting to really big amounts of meters there. There's the Eiffel Tower. Now, once we get to this size, or any bigger than that, we need a bigger unit. We call this a kilometer. So a kilo means 1,000. So 1 kilometer is 1,000 meters. So these are too big to just talk about them in meters anymore. So we need a bigger unit. So we use a scale which is bigger. We use kilometers. So these things are much bigger. And as you can see, there's a few more things that you might recognize the names of. And we're getting to the stage. Again, you're not going to know Everton on here, but you will have recognized some of these names. Mount Everest. A marathon is 26 miles, I think. So as you can see, these things are all in the scale of kilometers. If we keep going out now, these are on the scale. These things are on the scales of what we call megameters. So a megameter is 1,000,000 meters. So 10 to the 6 means there are 6 zeros after the 1. So 1 with 6 zeros after is 1,000,000. So 10 to the 6 means 10 times 10 times 10 times 10 times 10, 6 times, and you get 1,000,000. So here we go. These are, as you can see, small, these are small planets, small objects we find in the solar system, moons and planets. Pluto is there. We see the moon. We see other moons. There's the planets like Mars and Earth. All these are megameters we're measuring. That's the scale here. We keep going. I'm going to go a lot more quick now because we're not necessarily going to recognize a lot of these things. Here are some stars measured in gigameters, 10 to the 9, a billion meters. Or is it a trillion? A trillion meters, actually. Trillion meters. So these numbers are getting incredibly big. And of course, we don't really understand the size of these because we can't stand back and look at them. Look how far out we are here, bigger and bigger and bigger and bigger. And this stuff here is crazy stuff, 10 to the 15. So that's 10 with 15 zeros after it. See that big number? Massive amounts of meters. And like I said, most of that stuff we're not really going to have heard of or come across, but there's some of the galaxies. Andromeda is a neighboring galaxy. Milky Way there you see is our galaxy. These are crazy amounts of meters. Look how many meters that is. A zettameter, crazy amount. So a different scale than what we're used to. Okay, now if you want to have a look at this yourself, like I said, scale of the world 2, or scale of the universe 2, this simulation is called. I'm zooming right back in to the meter level again. This is our meter level. This is what we're used to seeing. Now, the same way I could zoom out though and make a bigger scale, I can also zoom in and see things which are much smaller than a meter. So if I start to zoom in, now I have things which are much more. These are a fraction of a meter now. Chicken egg that we're used to eating, quail's eggs are even smaller. Matchsticks smaller. We're getting down to the size now where we need to go to the next level down. We don't measure them in meters anymore. We're getting down to the stage where now we're talking about millimeters. So these are things which are measured in millimeters. So a millimeter is 1,000th of a meter. So take a meter divided by 1,000, you get 1 millimeter. So these are much smaller than a meter. So this is getting to a smaller scale now. And if we zoom in, and we can zoom in, and look how much further. If you look at this bar here, I'm still in the middle of it, and I can go all the way over to the left here. It's going to get smaller and smaller. Here's some things you're going to recognize the name of. There's a cell, a skin cell, for example, up here on the top right of the page is a skin cell. So much smaller than a meter. We're talking about less than 1,000th of a meter. So really small, okay? Here are some other things you're going to recognize the name of. Look, we've got the cell nucleus here shown in purple. And up in the top left there, we've got the chloroplast and we've got the mitochondria. These are all parts inside the cell that we've learned about. So these are smaller than cells. These are really small. We need a much smaller scale than what we're used to looking at in order to see these. This is why we can't really see these things with our eyes naturally. We don't walk around being able to see cells and being able to see different nucleuses, but it doesn't mean they're not there. They are there, we just can't see them. We need a scale that's smaller. So again, I can zoom in. Look, here's some things like viruses, like the big virus that's causing a problem at the moment. Smaller and smaller, and I'm zooming in. There's other viruses, HIV and hepatitis. But look how much further I can go. There's DNA, we will recognize that. See this phospholipid bilayer up here in the left-hand corner? That's a cell membrane. That's what a cell membrane is made of. So look how we're getting smaller and smaller and smaller here. So here's some molecules that we've been talking about before. And here's some atoms. There's a carbon atom. Look how small we are now. We're on what we call a nanometer, 1 billionth of a meter. So take a meter stick and divide it into a billion pieces. That's the size of a nanometer. And there is an atom. So really tiny. It's no surprise we can't see them because they're so much smaller than things we're used to seeing. And I can keep going into stuff that really crazy names that you won't probably have heard of, so we won't spend too long. But look how far it can keep going. 10 to the minus 33 meters, which basically means it's a 0.00033 times before you get the number. 0.0000033 times and then a 1. That's how many meters you have, a really tiny amount of meters. So again, stuff we're really not used to dealing in, so it can seem quite strange to us, okay? So Like I said, scale of the world too. If you want to have a Google of that, you can have a play around that simulation yourself. I love that simulation. It's really interesting, and it helps us to really compare things based on sizes. So going back to the board now, okay. Before we move on, I just want to talk. I'm going to add something that makes things a little bit more complicated to understand, but I don't want you to be afraid of this, okay? So it's the idea that we can swap between different units. So remember we had like kilometer and millimeter and centimeter and nanometer, all of those things. Well, we can swap between those units. So this is a really important skill in science. But don't be afraid of this. It's easy peasy. Okay. I'm going to show you how to do it. Okay. Now it all comes from the idea of, it comes from different words. Okay. So we use a word to describe a number. So for example, if we have the word centi, so CENTI. So first of all, everything is related to this guy. So imagine for a second that this is a meter long ruler. So when we have a ruler that's a meter long in science, we call it a meter stick. Okay, so this is a meter stick. It's a ruler that's 1 meter long. So it's bigger than your ruler that's in your bag, and it's exactly 1 meter. Now, everything in all our measurements are compared to that. That's 1 meter. Now, you can have things which are more than that, like a kilometer is 1,000 of them. And we can have measurements that are less than that. We can have measurements that are a fraction of that. For example, centi. This word means 100. Okay, centi. If you have a cent, you have 1 cent is 1/100th of a euro. So there are 100 cents in a euro. If you have a cent, you have 1/100th of a euro, and you need 100 of them to make a euro. So centi means 1/100th, 1/100. It's a fraction. Okay, we write this like this: 1/100th. Not 100, 100th. Okay, that means if you've got one of these, that means is you would take our meter stick and we would break it into 100 little pieces. Now I can't break that into 100 little pieces, but imagine each of these, there's 100 of these little spaces here. If I was to break our meter stick into 100 of those pieces, then one of those pieces would be a centimeter. There will be 100 of them in a meter. So one of these is 1/100th of a meter. Another word we can have is, oh yeah, so what we do is we take the word centi and we put the word meter after it. So a centimeter. Centi 100th meter is, well, we know the size of a meter. So a centimeter is 1/100th of a meter. And milli, this word here, milli means 1/1000th. 1/1000th. Not 1,000, 1,000th. So it's a fraction, 1,000th of a meter. So to do this, I would have to take my meter. I'm just going to have to rub out this. I would have to take my meter stick like this. And I would have to, this time, divide it into 1,000 pieces. So they would have to be even smaller. They would have to be even smaller this time, 1,000 pieces. So the lines here would have to be even closer together. So then one piece would be 1 millimeter. 1,000th of a meter. Okay, so 1 millimeter is 1,000th of a meter. So that means that 1 centimeter is bigger than 1 millimeter, because a centimeter only divides the meter stick into 100 pieces, and a millimeter divides the meter stick into 1,000 pieces. So that means, how much bigger than it is? It's 10 times bigger. 1 centimeter is equal to 10 millimeters, like this. So 1 centimeter is equal to 10 millimeters. If I wanted to change from centimeters to millimeters, so if I had a number of centimeters and I wanted to find out how many millimeters it is, I could do this. I could convert from centimeters to millimeters. Now, because 1 centimeter is 10 millimeters, so every 1 centimeter is 10 millimeters, I need to take however many centimeters I have and multiply that number by 10 to get millimeters. So, for example, if I had 7 centimeters, how many millimeters would I have? So to work this out, you're going to need a calculator. So what I'm going to do is I am going to put a calculator on the screen here. 1 second. I'm not sure. I hope that you can see my calculator here. It's on my screen. I'm hoping that it's also on your screen. So we would do 7. And what do I have to do? Well, every centimeter, I need to multiply it by 10 to turn it to a millimeter. So I've got 7 centimeters. I'm going to multiply it by 10 like this to turn it into millimeters. So 7 centimeters by 10 is equal to 70 millimeters, like that. Okay, I'm going to get you to try 2 now. I'm going to get you to try 2. So what if I had 12 centimeters? How would I do that? So work that out for me now. Pause the video now and calculate how many millimeters that is. Do it now, please. Okay, so you should have 12 centimeters. You should have also multiplied it by 10 to get the millimeters. It's 12 multiplied by 10 is 120 millimeters. Now remember, the number is getting bigger because millimeters are smaller. So for every centimeter, you would have more millimeters. So for every 1 centimeter, you have 10 millimeters. So the number has to get bigger when you go from centimeters to millimeters because there are more of them. What about this one? 3.5 centimeters. How many millimeters is that, please? Work it out for me on your calculator. Pause the video and do it now. Okay, you should only be watching if you have tried that. Again, no point in just sitting listening, guys. You won't learn anything. You have to try and do the tasks. So make sure if you haven't done it, do it now. Pause the video. Okay, this is what you should have. 3.5 by 10 is equal to 35 millimeters. Great. So when we go from centimeters to millimeters, the number gets bigger because there are more of them. And that means millimeters are smaller than centimeters. That bit's a little bit hard to understand. That if millimeters are centimeters, there are more of them. Okay, What if we want to go the other way? If we want to go the other way, go from millimeters. If we have millimeters and we want to go to centimeters, it's really easy. The number's going to get bigger. There are less centimeters. So if there's going to be less in the answer, you want to be dividing. And we're going to be dividing, same as before, by 10. Okay, so what about if I have 30 millimeters? How do I find out how many centimeters there are? Well, like I said here, I divide by 10 equals how many centimeters is that? So I get my calculator out. I'm doing 30 divided by 10 equals 3. And get 3 from my answer, and the answer is centimeters. All right, you do these 2 for me, please. Pause the video and do both of these now. So you've got 45 millimeters and you've got 90 millimeters. Do them for me now, please. Pause the video. Okay, so you should only be watching if you have completed them now. You have 45 millimeters divided by 10 equals 4.5 centimeters. Well done. And 90 divided by 10 equals 9 centimeters. Good job. Well done. And there are lots of different units we can do this for. We have meters, we have kilometers, we have nanometers. There are lots of different units. And so long as you know how to go between them, then it's easy. And we will look at other ones another time. So you now know how to go between meters and millimeters. So I've got a couple more for you guys to practice here now. So I want you to pause the video and try these 9 questions for me. Okay, coming up are the answers. All right, so you have to convert the below into centimeters. So these are millimeters, you have to convert to centimeters. So if you've got 10 millimeters, you need to divide by 10 to get the centimeters. That's 1. 10 divided by 10 is 1. What about 1,000 millimeters divided by 10? you get 100 centimeters. Okay, 902 divided by 10, you get 90.2 centimeters, like that. Next one, 81.3 divided by 10, you should have got 8.13 centimeters, like that. And the last one, 0.02, put that in the calculator, divide by 10, you're going to get 0.02. You've got another 0 in there, centimeters, like that. Okay, well done if you got that right. If you didn't get that right, you need to go back and watch that bit in the video again where I showed you how to do it. The next bit, you've got centimeters and you want to go to millimeters. So millimeters are smaller than centimeters. That means you're going to have more of them. They're smaller pieces. It's going to be more. It's like the pizza. Okay, if I cut the pizza into 6 big slices, and then your mother says, oh, there's more, we need to cut smaller slices because there's more of us to eat, then you would have to cut them into more slices. There will be more than 6. If you cut the pizza into more than 6 slices, then they're going to be smaller. Okay, so you've got 5 centimeters and we want to convert to millimeters. So if we're going to be more in the answer, we're always going to be multiplying. So multiplying by 10, 5 by 10, 50 millimeters. So the units changed. I now have millimeters, not centimeters. 28 by 10 is equal to 280 millimeters. 1000 by 10 is equal to 10,000 millimeters. And the last one, 0.009 centimeters by 10 is equal to 0.09 millimeters. Again, you use your calculator for this. We're always allowed to use a calculator in science. So absolutely, you should use it. Don't be trying to do it in your head or long division or long. So what's all this got to do with cells? Well, sometimes, cells, first of all, as you can see, when we zoomed in on that scale of the world, cells are small, okay? They're too small for us to see with our eyes, okay? Our eyes do not let us see things which are really, really small. So sometimes we have the problem that we have really small objects like this. This is a real object, and the object is too small to see. So what do we do about it? We have a real object and we want to see it. We're not able to see it. It's just too small for us to be able to see. Now I'm going to draw that actually even smaller. Do you know that? Because things that, like this, we're talking about things that are even smaller. So it really is, cells are really small. They're more like just a dot like this. They're really small to make out. You can't make out any detail about it. Okay, so this is a real object. And we can look at it, but we can't really see it. Now, what do we do if we want to see it? Well, if we want to see it, sometimes we need to take that object and we need to make it look bigger. And then we're going to be able to see the parts of the cell, like what we labeled. There's a nucleus, there's a mitochondria, here are some ribosomes. And those are the details, the structures inside the cell. Now, of course, when we look at the real object, we can't see that detail. So we're going to need to make it look bigger in order to see it. Now, this is what we call, so this is a real object. And this is what we call an image. Now, it's an image because it's only a blown up picture of the object. Some people think that when we do this, that we actually make the cell bigger. It doesn't. It just makes the cell look bigger. Now, this process of going from a real object and making an image that looks bigger, we say that we have magnified the object. So to magnify, we magnify the object and we make an image which looks bigger than the object. Now, of course, we don't take the object and really make it bigger because that would be magic. It would be some kind of crazy magic that doesn't exist. We can't just take an object and magically make it bigger, but we can make it look bigger if we magnify it. Now, what's all this got to do with science? Magnifying. Well, if we want to see these really small things, we have to magnify them. So how do we do this? Well, that's where this guy comes in. This here is a microscope. Okay, it's a microscope. Now, In a second, we're going to learn how to draw a microscope. But before we do that, we're going to answer a couple of questions. So here are your first two questions. What I want you to do when you get your practice copy out, okay, I want you to get your practice copy out, and we're going to do these first two questions for me. So make sure that you try these now, give them your best go. And the first question you have to say why the student is wrong. The student says that microscopes make cells bigger. They make cells bigger. Explain why the student is incorrect. And then the second one, you have to fill in the blanks. So I want to pause the video and complete those now, please. Okay, so you should only be watching if you have paused the video and completed the questions. Here are the answers. The student is incorrect because the microscope doesn't actually make the cells bigger. It just makes them look bigger. We said it makes an image. It doesn't actually make the objects bigger. That's why the student is wrong there, because the student said the microscope made the cells bigger. It doesn't do that. It magnifies and makes the cells look bigger. And in the second question, a microscope produces an image of an object that is larger than. So larger than is what's missing there, larger. So this is larger, like this, or bigger would be another way of saying it. Okay, it's larger than the actual object. And this process is called magnification or magnifying. Magnification is how we would describe it. It's magnification. All right, well done if you got those two right. You should have if you were listening carefully. Okay, and we're going to now learn the different parts of the microscope. Before we do, I just want to talk about the word microscope. This is it's all one word. This is a microscope. Where does the word come from? Well, it comes from these two pieces. It's got micro. What does micro mean? Micro means very small. Micro. So micro things are very small. Scope, this word means to look. Okay, so a microscope is for looking at very small things. Robert Boyle was one of the first scientists to use a microscope. He was an Irish scientist, okay, and he was the first one of the first people to look at cells in a microscope. Okay, he famously used a piece of wine cork, so a cork that's used to cork the bottle of wine. It's made out of wood, okay, and he was looking at a piece of it and was first able to spot the cells, okay, the cells that the wood was made of. Now, we're going to learn how to draw a microscope now and what the different parts are for. Okay, so what I am going to do is at different stages, I'm going to draw the microscope first of all, and I'm going to get you guys to draw it. So you're going to copy what I do, and then we're going to label it and say what each part is for. So the first thing I am drawing, I'm going to try my best to keep it nice and neat. So the first thing I'm drawing is a rectangle base. Okay, so I'm drawing a rectangular base. So you should do that now. Leave yourself plenty of space above, like I have. Leave yourself plenty of space above. So somewhere in your notes where you're practicing, you can start to draw this, please. Okay, so after you draw the base, then we are going to draw a rectangle upwards like that. Okay, rectangle upwards like that. Okay, you are then going to draw platform that sticks out from the side like that. Okay, we then have a rectangle up to the side that looks a bit like that. And then we have this guy here, which comes out and it goes down, and we've got 3 different little notches on this thing here like that. Okay, now this isn't perfect by any means. It doesn't look perfectly like this, but it's just a simple diagram. The last thing we're going to do is we're going to put a small square down here. Sorry, I'm going to fix that so it's better. Okay. All right, so that is the microscope. Okay, it's pretty rough, but it will do perfectly fine. There's one more piece we're going to add. We're going to add a circle here like this. Okay, Now, at this stage, I want you to stop drawing. So if you need more time, I want you to pause the video and finish off drawing that right now. Okay, so pause the video. Okay, so you're only watching if you've drawn the outline of what I have there. At this stage, I want you to stop drawing and I want you to listen. Okay. All right, this area here up at the top that I'm going to draw here, this is what we call the eyepiece. And the eyepiece is the bit that you look through. So this here is an eye and it's looking into the eyepiece. So the eyepiece is the bit that you look through. The eyepiece. These here are the objective lenses. This is the objective lens. It's called the objective lens because it's close to the object. This is the objective lens. These things here. There are 3 of these objective lenses. 1, 2, 3. So each of these is an objective lens. Sorry, I should probably do that from sugar. I should do that from this place. Sorry. Okay, so it's these 3 things here. These are the objective lenses, and there are 3 objective lenses. Call the objective lenses because they are closest to the object. Objective lens. So there are 3 here, and they will have different numbers on them. For example, this one could be 100. This one could be 40. This one could say 40, and this one could say 10. So 100, 40, and 10. There are 3 objective lenses. This is the eyepiece lens. Sorry, this here is the eyepiece lens. You look into this, the eyepiece lens. Eyepiece lens. Okay, so it's the eyepiece lens, and you look into it. You look down this lens. This here, this is the stage. This is the stage. And the stage is where you place the slide. And the slide is a piece of glass where you put the sample that you want to look at. Okay, so you might have some cells and you put them on a piece of glass and you put them on the stage. This is what you want to look at. This is the stage. So the stage is where you place the slide. You place the slide, which is a piece of glass with the object on it, on the stage. Place the slide on the stage. That's where we place the slide. Okay, so again, these are the objective lens and the eyepiece lens. You look down the eyepiece lens. So you look down this lens. You look down the eyepiece lens. The eyepiece lens and the objective lens, what they do is they make what we call the specimen, which is the substance or the thing that you're looking at, be it cells or pieces of living things. It makes the specimen look bigger. Remember, it doesn't actually make them bigger. It just makes them look larger. So the eyepiece lens makes the specimen look larger. It does this by what we call magnifying. It magnifies the image, magnifies. So it makes it look bigger. It magnifies the image. Okay, so the objective lens and the eyepiece lens magnifies the image, makes it look bigger. This here is the focusing wheel. Focusing wheel. When we look at the specimen at first, sometimes it's a bit blurry. We say the resolution is low, it's difficult to see. So this is the resolution. So the focusing wheel increases the resolution. So when you look at a picture on your camera and it goes all fuzzy, that means your resolution is lower. So the focusing wheel increases resolution. This makes the image look clearer. Makes the image look clearer. and this helps you to see more detail. So things like nucleus, mitochondria, those things, we need to see the detail. We need the image to be clearer. So we use the focusing wheel. So very quickly again, we've got the eyepiece lens. We look down this lens. We've got the objective lens, which is close to the object, and they work together. This eyepiece lens and the objective lens work together to make the specimen look larger. They work together to magnify the image. We've got the focusing wheel. The focusing wheel increases resolution and it makes the image look clearer so we can see more detail. The stage is where we place the slide. This here is the lamp. The lamp basically provides light so that you can see the image. So it provides light. You can't see anything without light. So if you turn off the light in the room and it becomes completely pitch black, you can't see anything. So you need light to see. So the lamp provides light. Okay, so these are the parts of the microscope, and we need to be able to draw and we need to be able to describe them. So what do we do with the wheel? Go back to the wheel. We turn the wheel, we spin it around when we want to make the image look clearer. Okay, so these are the parts, guys. So what I want you to do now is I want you to add these labels to your diagram. So pause the video and add the labels to your diagram now. Okay, so these are the parts and the labels. So what we're going to do now is it's time for us to do some practice questions. So up we go to the practice questions. Okay, so what I want you to do is I want you from memory to answer the questions 1, 2, and 3. All right, so in your practice copy now, answer questions 1, 2, and 3. Okay, so you should only be watching the video if you've done 1, 2, and 3. Hopefully they were easy peasy. Which of the parts is adjusted to change the magnification? Okay, the objective lens, the light source, or the focus wheel? Well, like I said before, maybe actually I probably didn't explain this properly, so I'm going to re-explain it now that I think about it. I told you that there are 3 objective lenses. So here is 1 objective lens 1, here is objective lens 2, and here is objective lens 3. Each of these has a different magnification. So the one that's 100 is obviously bigger than the one that's 40 and is bigger than the one that's 10. So the higher the number on these, the more it magnifies the image. And you can change which one of these is selected. Okay, so you can change which one of these is selected if you want to make the image bigger or smaller. So looking up here, as you can see here, here are the 3 objective lenses. There is one of them. There is another one behind there, and here is another one. As you can see, this one here out front here, this is the longest one. This would be the 100 one. This one here is this next one, it's the 40, and this littlest one is the 10. The longest one, the highest number, magnifies the image the most, so it makes it look bigger. The 40 makes it look in the middle, and the 10 one only makes it a little bit bigger. So maybe go back and try to do number 1 again, please. I didn't explain that properly. That's my fault. Sorry. Let's go again. Question 1. Okay. I'm hoping that you said which one of the following parts is adjusted to change the magnification. If you want to change the magnification, you change which of the objective lenses is selected. So you change the objective lens. To make this image of the specimen clearer, what would you do? You would turn the focus wheel to make it clearer. So you turn the wheel, it makes it look clearer. So if it's fuzzy or you can't see it, you need to turn the wheel until you can see it. Lastly, what is the name of the part you look into? The name of the part you look into is the eyepiece lens. Now, if you need to, oh, sorry, I don't have the answers done there. So it's the eyepiece lens. Okay. Next thing is, last little bit we're going to do now is we're going to look then at the actual magnification and how it works. Well, microscopes, as we said, have 2 lenses. They have the objective lens and the eyepiece lens. Now, what happens here is light. I'm going to show light with the yellow highlighter. Light travels up from the lamp. Actually, I'm going to choose a different color. It's hard to see. I'm going to choose green. Light travels up from the lamp like this. It goes through the specimen, it goes through the eyepiece that's selected, the objective lens that's selected. Then it goes up through the eyepiece lens where it gets magnified again. So let's go again from the start. Light goes up from the lamp through the specimen. It goes into the objective lens and it gets magnified. It travels through the microscope to the eyepiece where it gets magnified again, because this is a lens. Lenses are pieces of glass which magnify an image. It then goes into the person's eye and the person can see the light which has been magnified twice. Okay, so microscopes use two lenses, the eyepiece lens and the objective lens. We must use both of these if we want to calculate the total magnification of a microscope. So we need to know the magnification of the eyepiece lens. Now, most eyepiece lenses are always have a magnification of 10. They're usually 10, for example. Now, to get the total magnification, we want to combine it by multiplying it by the magnification of the objective lens. So magnification of the objective lens. Remember, this one is the one we can change. So we can select the 100, or we can select the 40, we can select the 10. So what we would do to get our total magnification, because remember, it's magnified twice, we'll take our magnification of our eyepiece lens and multiply it by the magnification of the objective lens. So say, for example, it was an eyepiece lens that was 400. So say it was a magnification of 400 was the objective lens. To get the total magnification, I would do 10 by 400. And when I put that on my calculator, I would get 4,000, like that. So my total magnification will be 4,000. I'm going to give you a few to do now. Okay. So I'm going to do the first one here for you here. As you can see, we've got eyepiece, which is 10, and an objective, which is 4. So we've got an eyepiece magnification of 10 and an objective magnification of 4. What's the total magnification? Well, as you can see, what did I do up here? I did 10 by 400. For this one, I need to do 10 by 4. So on my calculator, taking out my calculator here, I'm doing 10 by 4. That gives me 40. Total magnification equal to 40. Okay, so what I want you guys to do is I want you to do those other 3 for me. So pause the video and do the other 3. Right, so the second one here, you should only be watching the video if you've done these. The second one, total magnification is 10 by 10 is 100. Easy peasy, right? Should be really easy. This one is 10 by 40. That's going to be 400. And the last one is 10 by 100. Remember, guys, you're allowed to use your calculator. If you weren't using your calculator and you're getting them wrong, use your calculator now. Pause the video and do 10 by 1,000. Okay, 10 by 1,000. Oh, sorry, 10 by 100. 10 by 100 is 1,000. So the total magnification, this last one, is 1,000. Right? Time to do some more practice. Last ones, last little set here. Little bit of revision here for us. Name the 8 organelles. Quick reminder of what an organelle is. It's a structure we find inside a cell. So name the 8 organelles. Which organelles do plant cells have that animals do not? And then you have to find some of our total magnifications or overall magnifications. Right, do that now, please. All right, so you should only be watching the video if you have questions 1 to 4 answered here. Question 1, the parts, 8 structures inside a cell. Okay, well, if you weren't sure what these words, remember these were like nucleus was 1, nucleus. So now that I've told you, you might remember what are some of the other parts of the cell. Again, pause the video and try and remember. Write them down. Okay, right, let's go. Nucleus, we have mitochondria. We have ribosome. Again, tick these if you have them right. If you don't have them right, you need to add them in. Ribosome. We have cell membrane. And again, these should be flowing out of you now. You should know these. We've done these 2 or 3 times already. Cytoplasm. So nucleus, mitochondria, ribosome, cell membrane, cytoplasm. cell wall, that's 6, vacuole, and chloroplast, that is 8. Chloroplast. Just check them here. I've got 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we've got 8 altogether, and that's what you should have. So put them in, take them off, fix them. If you haven't got any of them added, you need to put them in there now. Put them into your answer now. Okay, I'm going to highlight. Question number 2 says, which organelles do plant cells have that animal cells do not? I'm going to highlight them in green because they're the plants. Here they are. A chloroplast. Plants have chloroplast, animal cells do not. Vacuole and cell wall. So these last 3. So write them in again for question 2. These last 3 are plant cell only. So we have cell wall, we have vacuole, and we have chloroplast. And that's how we would know. If we see these things inside a cell, we would know it's a plant cell, not an animal cell. If these things are not there, then it would tell us that that we're looking at an animal cell. Number 3, a student uses a microscope with an eyepiece of 10 and an objective magnification of 50. What's the overall magnification? Well, overall equals eyepiece magnification by objective magnification. So an eyepiece by the objective lens like that. So we've got eyepiece is 10 multiplied by objective of 50. So 10 by 50 overall is equal to 500. Good, well done if you got that right. And number 4. Okay, so we've got the same objective magnification, but this time we have an eyepiece magnification of 5. Okay, so this time it's still 50 is the objective magnification, but the eyepiece has been changed for a different eyepiece. It's now 5. So it's got 50 by 5, be 250 is the total magnification. Well done, guys. Okay, so we've got a good start on magnification. We love to do this experiment when we're in school. So when you're back in school, your teacher will usually, hopefully, I will do it with my class anyway. We will use a microscope. We will learn how to actually hold it and use it and look at some cells. But it's important that we understand the concept behind how it works as well. Okay, so I'll see you in the next video. If you could, guys, if you give the video a like, it will help other students find a video who need help with science. It'd be really good. So if you can like the video, you'd be really helping us out. Thank you. See you in the next video.